Imagine squeezing more life out of your old GPUs, running those massive AI models that were once only a dream. Perplexity, the AI search innovator, has cracked the code. Their research team has unveiled clever software tweaks that enable trillion-parameter AI models to run efficiently on older, more affordable hardware, all while leveraging existing network tech like Amazon's Elastic Fabric Adapter, EFA. These game-changing advancements, meticulously detailed in a recently published paper, https://arxiv.org/abs/2510.27656, and openly shared on GitHub, https://github.com/perplexity/pplx-garden, for community scrutiny, offer a fresh perspective on tackling one of the biggest hurdles in deploying large-scale mixture of experts, models, the insatiable appetite for memory and the frustrating delays caused by network latency. Think of it as giving your existing tech a supercharged upgrade, allowing it to punch way above its weight class. Mo parameters, Mo problems, solved. Mo models, the giants of the AI world like DeepSeek v3 and R1 or Moonshot I's Kimi K2, are huge, packing anywhere from 671 billion to a staggering 1 trillion parameters. This sheer size makes it nearly impossible to run them on systems equipped with older H100 or H200 GPUs at scale, particularly those with only 8 GPUs. While you might technically squeeze the model weights in, you'd be left with virtually no memory for the crucial key-value caches, the model's short-term memory, which are absolutely essential for serving it effectively. It's like trying to drive a race car with an empty gas tank. So, what's the workaround? You either need astronomically expensive, cutting-edge systems, or you need to cleverly split your models across multiple, smaller systems. The seemingly obvious solution would be to throw money at the problem and deploy these models on NVIDIA's GB200 or GB300 NVL72 rack systems. These are basically monolithic servers boasting a whopping 72 GPUs, each with 192 GB or 288 GB of memory, more than enough to handle even the most gargantuan multi-trillion parameter LLMs. Unfortunately, there's a catch, or several. These systems are incredibly expensive, in extremely high demand, and their availability might be limited depending on your location, China. In contrast, older H100 or H200 based systems are far more readily available and significantly cheaper. However, using them requires distributing your models across multiple nodes, which, historically, has meant a major performance hit. But here's where it gets controversial. Are the cost savings worth the performance trade-off? These performance penalties are further amplified by the shift from dense models, where all the weights are accessed for every token generated, to sparse Mo models. In Mo models, requests are intelligently routed to a smaller, specialized subset of weights known as experts. Each token, a word fragment or punctuation mark, for example, can be generated by a different set of experts. This architecture offers a significant advantage. It reduces the amount of memory bandwidth needed to achieve a desired level of responsiveness. On the other hand, it dramatically increases network communication. It's like switching from a direct phone line to a conference call with dozens of participants. Within a single node or rack system, high-speed interconnects like NVLink or AMD's Infinity Fabric can easily handle this increased traffic. However, when models are distributed across multiple nodes, the model experts might be running on GPUs in completely different systems connected by interconnects that are 7 to 14 times slower. That's a massive bottleneck. To address this challenge, the developers behind DeepSeek v3 created DeepEP. EP stands for Expert Parallelism. DeepEP is a software framework specifically designed to minimize the performance impact of running models across multiple H800-based systems connected using NVIDIA's ConnectX and ICs. Amazon complains that Perplexity's agentic shopping bot is a terrible customer, https://www.theregister.com/2025/11/05/0 Perplexity commit legal threat. Perplexity rips another page from the Google playbook with its own browser, Comet. https://www.theregister.com/2025/07/09/ Perplexity Reddit to Perplexity. Get your filthy hands off our forums. https://www.theregister.com/2025/10/22/Reddit Perplexity. Perplexity offers training wheels for building AI agents. https://www.theregister.com/2025/0/30/Perplexity_agent. Cutting the EFA overhead. Perplexity's secret sauce. The key takeaway here is that not everyone uses NVIDIA's NICs. Amazon Web Services, AWS, for example, has its own networking protocol called Elastic Fabric Adapter, EFA. While EFA, like NVIDIA's ConnectX-7 NICs, supports up to 400 gigabits per second of aggregate bandwidth, Perplexity's research highlights some crucial shortcomings. And this is the part most people miss. It's not just about raw bandwidth. Perplexity points out that EFA lags behind NVIDIA's NICs in handling the message sizes exchanged during Mo dispatch and combine operations. Additionally, EFA lacks support for GPU direct async, a technology that allows NICs to bypass the host CPU and communicate directly with the GPU. This lack of direct communication forces EFA to proxy data through the CPU, leading to a noticeable latency penalty in certain workloads. To overcome these limitations, Perplexity has developed a new set of kernels, highly optimized software routines that manage communication between GPUs. They claim, https://research.perplexity.ai//articles/enabling-trillion-parameter-models-on-AWS-EFA, that these kernels achieve even lower latency than DeepSeek's DeepEP on ConnectX-7 NICs, making EFA a viable option for distributed inference on Mo models. Compared to DeepSeek's existing DeepEP libraries, Perplexity's kernels demonstrated slightly better performance in specific metrics when running on NVIDIA's ConnectX-7 while significantly reducing EFA latencies to acceptable levels. To validate their findings, Perplexity tested the kernels on its in-house inference engine using both DeepSeek v3 and Kimi K2, running on a series of AWS H200 P5en instances, leveraging EFA for internode communication. While DeepSeek v3, at just under 700 billion parameters, isn't quite a trillion parameter model, it's small enough to fit on a single H200 instance, providing a solid baseline for evaluating performance gains. In their tests, Perplexity compared the performance of a single 8-GPU system against multi-instance setups with 16, 2 instances, or 32 GPUs, 4 instances. While performance remained relatively consistent at low and high batch sizes, they observed that higher degrees of expert parallelism in the multi-node configurations resulted in superior performance at medium batch sizes. These performance improvements also extended to larger models like Kimi K2, which is far too large to fit on a single instance. Even with the bandwidth limitations compared to NVIDIA's NVLink or AMD's Infinity Fabric, which can be up to 14x faster than Ethernet, Perplexity was able to demonstrate significant performance gains at medium batch sizes for multi-node inference. Perplexity's work to further optimize their kernels for Amazon's EFA network technology is ongoing. They're actively tracking updates to Amazon's libfabric libraries to reduce data plane overheads and plan to experiment with EFA Direct to further minimize latency and improve overall performance. The real winner here might be those who can now extend the lifespan of their existing hardware or take advantage of discounted instance types on AWS without sacrificing access to cutting-edge AI models. It's about getting more bang for your buck and democratizing access to powerful AI. Now, here's a question to ponder. Does this advancement shift the balance of